Hey guys, how's it going? Mr. Dorado here with another video on Chapter 2. Today we're looking at Section 2.6, which is focusing on slope as a rate of change. So we've talked about slope and how this is the rise or the run. The rise over the run, and how it relates to a graph. But now we're actually going to look at it as a rate of change. So let's go ahead and get started right away on this first problem here. So it says finding slope from a graph. So slope equals the rise or fall over the run. Okay, so how much up or down, and then how much left or right. And actually for run, we always run to the right. Okay, so that maybe is a little note you should write yourself. We always run to the right. Okay, so it's always going to be a positive number. And now we will talk about sometimes where you do have to go to the left if we wanted to graph points on the other side of the line, but we'll talk about that a little later. Just remember for now that run is always to the right. So let's go ahead and see if we can figure out our slope here for this first problem. So I'm going to start from this point right here on the left, and I'm going to get to the point here on the right. So first, rise or fall. Well, actually I have to rise here, so 1, 2, 3. So my rise and run is, I went up 3, and then I'm going to go to the right, 1, 2. I went to the right, 2. So what is my slope? My slope is 3/2. Okay, so my slope is 3/2. So let's go ahead and calculate now the slope given points right here. Okay, so finding a slope from a point, let's go ahead and name these 2 points here x1, y1, and x2, y2. And what we're going to do is just going to go ahead and apply our equation to find the slope, which is m equals y2 minus y1. So in this case, it would be -5 minus a -1 over x2 minus x1, which is 4 minus a -2. So let's see what we get. This is actually going to turn into a positive because it's a double negative. So we have -5 plus 1 is a -4. And then same thing here, a double negative. So the opposite of a negative is actually positive. So we get a 6. Okay, let me actually change that to green. So -4 over 6, we know we can reduce that. Okay, these are both actually divisible by 2. So if I divide the top by 2 and the bottom by 2, my final answer here is -2 over 3. So this is my final answer. That's my slope. Okay, now when we talk about slope as a rate of change, we're going to talk about rate of change with function notation. Okay, so let's go ahead and see if we can calculate that. So it says rate of change is f of x2 minus f of x1 over x2 minus x1. What does that mean? It means that for the m, we have to, or for the slope, we have to subtract the y values for the ones that are on top over over subtracting the x values. So again, subtract the y values on top and then subtract the x values on the denominator or in the bottom. Okay, now why did I just suddenly start calling those y values? Well, we've talked about guys that if a equation qualifies as a function, then we are allowed to say that y equals f of x. Okay, meaning that this right here is really y2, and this one here is y1. So basically it's the exact same thing as what we have up top. for our slope equation. Okay? So it's basically the same thing, except for now we're writing it as function notation. So just remember this in the back of your head, guys, that y equals f of x if it is a function. Okay? Let's go ahead and try out one of these problems. It says, given f of x equals 4x minus 3, show all work to determine the average rate of change between f of negative 2 equals negative 11 and f of negative 5 equals negative 23. So, once again, guys, let's go ahead and see if we can figure this out. Now, let's focus on this for a second. That f of negative 2 equals negative 11. Okay? Well, notice again what I have up here. Another way of rewriting this little equation here, let me go ahead and make a little arrow if I can, is the same thing as f of x equals y. Okay? Y equals f of x is the same thing as f of x equals y. No biggie, right? But now look, doesn't this look awful similar to that? Okay? So we have to identify which one's our x value, which one's our y value. Well, our x is the one that's right here in parentheses, so that means that this negative 2 is my x. Okay? And also here on the other side of the equal sign is my y, so I know that this negative 11 has to be my y. Okay? Same thing over here. This is my x, this is my y. And just to remember, we are calculating average rate of change, which means we have to calculate slope. So what I'm going to do is actually call this my x1, y1, this my x2, y2. Okay? So that's all I'm really doing. And again, I'm calculating slope. Okay? Or another way to do it is just like we have up here. So let's put f of x2, which is that, let's see, let's go ahead and try this out. So we have m equals, all right, let's see, give me 1 second, guys, sorry about that. All right, let's see if we can figure this out. So our y2 is, in this case, a negative 23 minus a negative 11, okay, over x2, which is negative 5 minus a negative 2. Okay, so what do I get? Well, this is technically turning into a positive, so I get negative 12 over, again, another positive here, over negative 3. Those both have a negative 4 in common, so if I divide them out, this actually has, I'm sorry, a negative 3 in common, so if I divide them out, I get m equals 4. So again, let's recap. My f of x2, which was kind of like my y2, is this one, okay, minus f of x1, which is my y1. All right. Then we have our x2, x2, x2. Oh, I forgot to highlight this one. And then finally we have x1, x1, x1. Okay? So as basically this rate of change equation, guys, is excuse me, is your slope equation. It's the exact same thing. Okay, so rate of change is your slope equation, which we know the slope equation is just the m. So what does that mean? That m is a rate of change. Okay. So that was a little tricky because we kind of went all over the place. So let's go ahead and see if we can try out a new problem here. So it says, given f of x equals negative 1/3 x plus 4, show all the work to determine the average rate of change between f9 equals 1 and f negative 6 equals 6. So again, if you remember your equation, let's go ahead and write it down. It's f of x2 minus 1 over x2 minus x1. All right, so let's go ahead and figure out which ones are x's. Well, remember, in the parentheses is always your x. So these two are my x's, and these two are my y's, or rather my f of x's. So again, this is x1, y1, x2, y2. Let's go ahead and substitute that in here. So f of x2 is whatever f of x2 produces, which in this case would be my y2. Okay, so f of x2 is my y2. So we're going to go ahead and write 6 minus f of x1, which is right, whoops, here, which is my y1. Let me actually change that color. Okay, so what number was that? That was just a 1. So 6 minus 1 over. Now I just have to use my x1 and x2, which are right here. Okay, so my x1 and x2. So what values are those? Well, that's just a negative 6 minus 9. So I get 5 minus 1, that's, or sorry, 6 minus 1, which is just a 5. Negative 6 minus 9 is a negative 15. So I get, let's see, those are both divisible by 5. So what is my final answer here? It is 1/3, negative 1/3 to be exact. Okay, negative 1/3. Okay, so hopefully you guys have already noticed something on here, but if you haven't yet, I won't mention it just yet until the end of the lesson. Okay, so we found our slope. It is m equals negative 1/3. So let's try out the second. So once again, you can either think of the slope equation in this form, guys, or you could think of it in this form. y2 minus y1 over x2 minus x1. This right here, whoops, this right here and this right here are the exact same thing, okay? So if it helps to write it in this form rather than this form, then go ahead and try that out. So let's see, let's go ahead and identify what we're being asked. So it says, given f of x equals 2/5 x minus 1, show all the work to determine the average rate of change between f negative 10 equals negative 5 and f negative 5 equals negative 3. Again, it says find the average rate of change, and as we saw earlier, the average rate of change just means the m, which is exactly what I'm going to calculate, the slope. All right, so again, let's identify our x1, y1, x2, y2. Again, if you think back to this right here, always remember that, guys. F of x equals y if it is a function. So inside the parentheses is my x, so I'm going to call this my x1. And outside of the, or on the right side of the equal sign is your y. I'm going to call this y1. Then I'm going to call this my x2, y2, and go ahead and start substituting values in here. So what do I get? I get negative 3 minus a negative 5. And then I get a negative 5 minus a negative 10. So what do I get? Let's see. These two turn into positives, so that turns into a positive, that turns into a positive. So my answer here is negative 3 plus 5 is just a positive 2. Negative 5 plus 10 is a positive 5. So my slope here is a positive 2/5. Now, I want you guys to try out number 3, and I want to see if you guys can actually identify what's going on here. And I want to be able to answer this question right here after we finish problem number 4. Okay, so start looking at this piece of information that we're given right here, guys, see how we're given an actual function, and start comparing that to the answers that you're getting, and you'll start to notice that there's a little bit of a connection there. Go ahead and try out number 3 on your own, and we will come back to check to see if you did it right. All right, guys, let's go ahead and take a look at problem number 3. Okay, so it says, given the function f of x equals negative 2x minus 6, show all the work to determine the average rate of change, so we know that's our m, between f of negative x, f negative 8 equals x, oh my god, I keep saying that, f of negative 8 equals 10, and f of 4 equals negative 14. All right, now I was able to say it. So once again, remember, if we think back to our f of x equals y, right here, always keep that in the back of your mind. We can actually go ahead and identify which one are x's and which ones are y's. So this, inside the parentheses, we know it has to be the x's. So x1, this will be x2, and what's on the other side of the equal signs are your y's, so y1 and y2. So let's go ahead and use our slope equation, y2 minus y1 over x2 minus x1. Let's just substitute our values in now. So what do we get? We get a negative 14 minus 10 over 4 minus a negative 8. So what is that? That's a negative 28. This turns into a positive, so it's a positive 12. If you, I'm sorry, not a 28, 24. Sorry about that, moved a little quick there. And so we get a negative 2 for my slope. This is our final answer here, okay? Now, again, compare that slope that we just found to something in the original equation, in the original function, and you'll start to notice some similarities. All right, so hopefully you guys got number 3 right. Let's go ahead and try out number 4, see how you do on that. So it says, given f of x equals negative 1/3 x plus 1, show all the work to determine the average rate of change, so our slope, of f of negative 9 equals 4 and f of 3 equals 0. So once again, I can label this as my x1, y1, x2, y2. So if I use my equation, and again, you don't have to keep rewriting the equation like that, guys, but if it helps, go for it. So we get 0 minus 4 over 3 minus a negative 9. This is a negative 4 over a positive 12. That reduces, those are both divisible by what? They're both divisible by 4. So I get an answer of negative 1 over 3 for my slope. All right, so what I'm going to do right now is highlight in blue here my slopes. Okay, negative 1/3. I want you guys to identify where you see negative 1/3 in the function that we were given. And hopefully you guys see it there. That's kind of cool. Let's go up and look at the previous one. My slope was negative 2. Do I see negative 2 anywhere on my equation? I'm sorry, on my function here? Yeah, it's the coefficient in front of the x, just like in problem number 4. So, keep going. Double check our answers for this one. Well, 2/5, and actually I should probably do that a different color because you can't really see that. Let me highlight it in this lighter blue here. 2/5. Where do I see it here? Well, I see it again, coefficient in front of the x. And finally, let's see, the coefficient in front of the x, that means our slope should have been negative 1/3. And would you look at that? It is. Okay, so to answer problem or question number, well, there's no number here, so let's just answer the question. How do we know that our answers are correct? We know the answers are correct if Whoops, no need for that comma. If the answer matches the coefficient in front of the x value in our linear function. Okay, so what we did was we went back and checked all of our answers, and if we notice each time they were exactly the same as that number that's in front of the x, that coefficient in front of the x. So let's go ahead and see this last part. It says, I challenge you, rate of change in applications. So Belle has been writing a paper for the past 2 days and has tracked the number of pages she has written. Which graph below represents her progress? Use vocabulary you have learned in this unit to help in your description. So once again, let's read the scenario again. Belle has been writing a paper for the past 2 days and has tracked the number of pages she has written. Okay, so let's look at both of these graphs. Okay, so I recommend that you guys go ahead and look at the graph number 1 and try to see if you can identify by looking at the axes. So again, take a look at what the y-axis represents and what the x-axis represents. Okay, and do the same thing for graph number 2. Okay, look at again what do each of these axes represent and see if you can figure out which one is the graph that models her situation. Okay, so go ahead and take about, I don't know, I would say take about like 2 or 3 minutes. So pause the video, take about 2 minutes, and try to see if you can identify which one of those models the above situation. Okay? Okay, so let's go ahead and take a look at graph number 1 and see if it would accurately model what's going on. So the x-axis represents hours spent writing, and the total pages written is described by the y-axis. Okay, so notice where she starts. Let me go ahead and highlight right here where she starts. So before she starts writing again, so at 0 hours, she already has 10 pages. Now, as she is increasing, or as she's going to the right, so as more time is passing, right? Look at what's happening in the y. Okay, so look at that. As I went to the right where it's 3 hours, she has written 20 pages. So this seems to be modeling it pretty well. As more time passes, then the total pages that she's written is increasing. Let's see if that keeps happening. Now over here at 6 hours, she is at 30 pages. So again, she started at 10. After 3 hours, she went to 20 pages. After 6 hours, she went to 30 pages. So it looks like this graph is modeling what? It's modeling that as more time passes, so let's go ahead and write that down. As hours increase, and I totally misspelled that. As hours increase, the number of pages written also increases. So that looks like a good candidate for which of these graphs represents our model, okay, or our particular situation. Now let's take a look at graph number 2. Let's see if this one may also represent that. So I'm going to go ahead and see where I start. I start right here at 0 hours. So at the very beginning, I'm already at 90 pages, or rather, Belle is already at 90 pages. Okay? Now, what do you start to notice as more hours pass? So let's see at 3 hours. Okay, at 3 hours, where am I at? Well, I'm right here. So what do you start to notice? Whoops, that was totally horrible. So as I go from 0 hours all the way to 3 hours, how many pages do I have written now? Well, according to this, I started out with 90, and now that I got to 3 hours, I'm at 80. Well, how could that be? How could you write less pages? Or rather, at that point, it seems like you're deleting pages, right? You're not making any progress. In fact, you're going the exact opposite way. But let's see if that continues. What about at 9 hours? Okay, so as more time passes, all the way to 9 hours, where is my graph? Right here. Okay, so let's mark that with purple. All right, so what does that mean? At 9 hours, how many pages do I have? I have, or Belle has, 60 pages. Well, that doesn't sound right. You shouldn't be getting less pages or writing less pages as more time passes. So, again, Belle has been writing a paper for the past 2 days and has tracked the number of pages she has written. So as more time is passing, she's supposed to be gaining more pages written. So definitely it looks like graph 2 would not be it. So we would say that our answer here is that graph number 1 models Belle's situation. And it's modeling it because of this reason right here. We already wrote it up top. It's modeling it because as hours are increasing, the number of pages are also increasing. Okay, which makes sense. That's usually how it works. The more time you spend writing on a paper, the more pages you are actually writing on that paper. So graph number 1 is the winner. Graph number 2 is not. All right, guys. I think that is it for today. All right. I think that's it. I think that's all we have for today. So what I want you guys to do is stop the video at this time and go ahead and practice your homework for 2.6 day 2. All right, guys. Have a good one.